Hello everyone. Today in this video I'm going to explain how exactly you can convert a 3D CAD model of a quadrotor into a URDF file. So you can import that into Gazeebo and perform the required simulation. So in order to do that, you will be needing a tool called SolidWorks to URDF that you can download from this website here, wiki.ros.org. Or you can directly search on Google the SolidWorks to URDF exporter and you'll come on this page. From here you can download it and install it. Once you'll install it, you will see this tool here in this tools option of the SolidWorks here, the export as URDF. Okay. Before I start the conversion, I would like to mention that I have downloaded this 3D CAD model of the quadrotor from the repository of Crazyfly version 2. It is a repository maintained by Crazyfly on GitHub. So I downloaded it from there. Okay, just for the explanation purpose, how exactly we can convert a CAD model into URDF file. Okay, so let's start. So first go here and click here on export as URDF. Click yes. Now you'll see a window like this. Okay, now you'll have to create the base link first. So let's select the entire quadrotor. Now we know that the stationary part will be here, this entire part, the body of the quadrotor, and the rotatory part will be just the rotors. So I'll just deselect these rotors and keep this entire blue section of the quadrotor as base link. So we have selected all that parts and all are here. If you want to deselect, you just need to click here and you can delete the individual part, or you can click here on the individual part and it will automatically get deselected. Okay, so we are fine with that. Now as the base link has been created, we need to create 4 child links for individual rotors because they will be rotating. Okay, so let's create 4 child links here. Okay, so the first link is, let's say this is our x-axis, the forward position. So we will select this as first rotor. You can choose any of them as first rotor because once the URDF file is converted, you can actually modify that as per your requirement, the numbering system. Okay, so let's select this as the first rotor link. Okay, but before that I think we somehow went back to the main page. So again you'll have to click here and come here. Because we didn't save this configuration, this problem will arise again and again. So I would suggest every time when you are working on this, save your work. Okay, let's start again. I'll just deselect it, this and this part is done. Now let's add the child links. Let's click on the first one. Now I'll select the first rotor, this one, and name it as rotor 1 link, and then rotor 1 joint. Okay, let's keep the naming convention as I have written here. Okay, now since this rotor is actually be rotating about the vertical axis, so let's give it a revolutionary motion here. Actually sometimes it automatically detects when the quadrotor model or any model that you want to convert is designed in a very proper way. Okay, but we are not sure about the connections and the moments that have been provided in this CAD model, so I'll just choose the revolute motion for this propeller. Okay, now I'll go for the second link and I'll create rotor 2 link. I'll just copy it, paste it here and name it joint. Okay, and let's select the second rotor here. Okay, again provide revolute. Now third one, let's paste the name, type rotor 3 link and rotor 3 joint, again revolute. This is the third rotor. Okay, similarly for the fourth one. So 4, and this will be the fourth joint. Okay, and let's select this fourth rotor here and revolute motion for this. Okay, so now we have this. Let's just save it now. Again, you have come here on the main page, but now you have this extra option, URDF export configuration. Okay, so now if you'll go on this tool again, you will see your settings here. Okay, this is the good part. Okay, so now because we have actually provided all the settings here for the motion, for the base link, for the individual rotors, everything, so let's preview and export. Once you click this preview and export, it will generate the access system for individual links and joints, and I mean that we will be actually seeing in a moment actually how we will be using those access system, or if we need to modify them, how we'll do that. Okay, so this configuration window will appear after clicking there. So you can see here joint 1, 2, 3 and 4, but in this you can see the orientation part here, the roll pitch here, it's not 0 everywhere. Similarly for 2, 3 and 4, it's not 0. For 3 it is 0. That means it is aligned properly, but what about 1, 2 and 4? They are not. That means the overall alignment and the axis reference system is a bit not working in a manner actually we want, so we'll have to modify that. So what I'll do is I'll just minimize it for for a moment, and then what I'll do is I'll start checking and modifying the reference system for individual rotors as well as the global joint. So if I'll click on this origin global, you can see it is somewhere outside the frame of reference of the entire vehicle, but we need this at the CG of the quadrotor. Okay, similarly this one, the first one, it is at the right point, but the X, Y and Z, the north, east, down, or the reference system that we follow in Gazeebo is not matching with these reference systems. Okay, so we'll have to modify them. Let's say we are following the north, east, up. Okay, reference system, so we'll follow that, and based upon that we'll change the directions of the reference system. But before that we'll have to bring this origin global at the CG, so we'll have to actually first create a point somewhere here so we can select the origin for that. So for that I'll do one thing, I'll just hide this components temporarily, this one also, and I'll create a sketch, a point sketch. Okay, I'll come here, I'll just click on the point, I'll select this plane and I'll find the center. This is the center here. Okay, and I'll create a point here. So this is the point now. Okay, I'll just save it. Okay, now you can see, now you can also unhide the components. Okay, done. So now you can see the sketches here at the CG, but this sketch point is actually at the end of this entire tree, so we'll have to actually shift this in the beginning of the access systems here actually. Okay, so now this point is actually accessible by all these joints, links and access systems. Okay, so now we can start with the proper assignment of the reference system. So I'll just start with the origin global. Okay, so what I'll do is I'll just go on the assembly section here and click on the reference geometry and select the coordinate system. Okay, now this is the origin global, which is somewhere here. Okay, let's assume this is the x-axis and the vertical is the y-axis, and based upon that we'll be generating the z. Sorry, the vertical is the z-axis, and based upon that we'll be generating the y-axis. So first I'll bring this origin global here. So I'll select this point and select this point. So see, now it is here. But right now the z is in the downward direction. The y-axis is in direct, I mean pointing in the left direction, and the x-axis is pointing in the forward direction. Okay. So what I'll do is, just give me a moment. Okay. Okay, so what I'll do now is I'll just select the proper alignment. So here is the x-axis alignment, y-axis alignment, and z-axis alignment. I'll click on x-axis alignment, and because I'm assuming this as x-axis, I'll select this edge. Okay, so now you can see the direction of the x-axis is pointing in the forward direction. Okay, and z in the upward direction. But here we have not given any reference, so I'll just give reference for the safety purpose for the z also. Let's select this edge here as z. Okay, but now the z is in the downward direction, so we can switch it. Now you can see the proper direction. Okay, x in the forward, z in the z is pointing in the vertical direction, and y is in the left, pointing in the left direction. Okay, now we can save it. So our global system is here. Okay, now here I purposely did this. Every time when you'll just click on this reference system and generate some reference system alignment, so what will happen is it will create a new coordinate system here. So every time when you'll do this, some new coordinate system will come. This has come for the origin global. Similarly for origin rotor 1, some other point will come, some other reference axis will keep coming for every point. But we don't want a lot of axis systems here or the copy of them. So what we'll do is I'll just delete it for now, because we have created. I'll just delete it. Okay, now the global system is again there. Okay. Okay, so now what we'll do is we'll just go on this point and edit feature. So once we'll start editing this, we'll see this window again, and now you can actually click this point to assign the origin of this axis system. Okay, here, see, now it has come here again. I'll just delete these reference systems here and here and assign the x in this direction and y in the vertical direction. Any edge I can select. Okay, I selected, and now it is in the correct direction. Okay, I'll just save it for now. Okay, now I'll do the same thing for this rotor 1 joint. The point reference point is correct, so I will not change that, but the x and y alignment I'll delete and reassign. Okay, so this x alignment can again be this edge, and z can be any vertical edge. I'll select again this one. Okay, so again it's correct now. Okay, if you want to assign y, we can assign y also. Let's give this edge. See, okay, and save it. Now let's go for the second rotor. The origin point is correct. The x and y alignments need improvement, so we'll select x and this will be y and this will be z. Okay, again it's correct, so I'll save it. Now I'll go for the third one. The point origin point is correct. I'll just assign the x, y, z again. X, sorry, it's in the Y, so I'll delete again. Let's select the X alignment, the Y alignment, and the Z alignment. Okay, now it's correct, so I'll save it. Let's go for the fourth one. Okay, now again the origin point is correct. Let's go for the XYZ alignment. For the X, let's select this one. For the Y, let's select this one. For the Z, let's select some other X age this time, this age, let's say. Okay, this is for the Z. So again, it's aligned properly. Okay, let's save it. Okay, so all are saved now. Okay, the origin global is correct, the rotor 1 is correct, the rotor 2 is correct, rotor 3 is correct, rotor 4 is correct. Okay, now this is the configuration window that we had opened earlier, right? So I'll just cancel it. Now it will ask you to save the configuration settings that we have changed, so we'll say yes. Okay, and now we'll rerun this. Okay, so again we got this. Instead of continuous, here we'll select revolute. Now this time you can see in the previous window, when actually we were setting all this, you were seeing the automatic options here, but here this time all the axes and joints have been already allotted for the child links. Okay, for the first, you can see the first joint and the first axis, right? Similarly for the second one, we'll just give it revolute instead of continuous. Similarly third one, the revolute setting. Similarly for the fourth one. Now you have the correct settings. Okay, so let's preview and export. Now this time you can see new access systems has not appeared here. Why? Because we have already modified the system and saved it. Okay, now if you'll click individual settings here for the rotor joints, you'll see all 0. The orientation is perfectly aligned, right? You can see, and the rotors are rotating about the Z axis, which is in the vertical direction. So for all the revolute motion, you can see one has been set up for Z option. Okay, so all alignments are correct here. Now if you want to give some extra velocity, the upper limit, lower limit for the rotation, when actually these settings you want to use in the gazebo environment, that you can also provide here. Okay, but these things you can modify later also, that's not a problem. Okay, so we'll just keep this setting as it is and ignore other settings for now and go for the next settings. Here it is. Now for the base link, if you'll see the origin and the other inertia properties. Similarly for the first link, second link, third link, and fourth link, you got everything in a correct manner. Now just go and select the mesh details, whether you want to select chorus or fine. I'll just select the fine one and export URDF and meshes. I'll just export. Now try to give as short name as possible with don't use any capital letters in that. Just use the small letters and assign any smallest name. So I'll just go with the crazy. Okay, or if you want to write up full name, that is also fine. Crazy fly. Okay, and I'll save it. So it will show this option to you. So just click OK and it will start saving all the options there. So everything has been saved in a folder. I'll just save it now, the entire model that we have actually prepared. So all the settings will be saved. Okay, and I'll close it. Okay, that's it. Now here on the desktop we can see this folder crazy fly. In this folder you'll find all the files. The URDF file is here. You can see this for the base link. Okay, for the rotor 1 link, the rotor 2 link, the rotor 3 link, and the rotor 4 link. All settings that we exported are here in this URDF file, and the mesh are available here. Okay,